Here's your real number system unit review sheet. Explained. Plot the numbers on the number line. So I see that they're all square roots. So remember when we're putting in square roots on a calculator, we hit the second function button and then x squared to get that square root symbol. So the square root of 3 is approximately 1.732, and then it goes on and on. The square root of 7 is approximately 2.645, and so on. The square root of 25, well, that's a perfect square, so that's exactly 5. And then the cubed root, remember to put in a cubed root, we hit 3, and then second function, and then the caret key button. So the cubed root is 64. That's going to be a perfect cube, which is exactly 4. Now that I know that, I can put them on the number line. So 1.73, like $1.73, that would be almost 3/4 of the way through between the 1 and the 2. So the square root of 3 goes about right there. 2.64, that's just over the halfway point of 2. So the square root of 7 goes here. And then the last two are easy because they're perfect squares and perfect cubes. So the square root of 25 is exactly 5. And the cubed root of 64 is exactly 4. Okay, notice I put the original values on my number line. Okay, next we're going to simplify. So let me put those reminders on there again. Okay, so there's our keys to access the square root and the cubed root on our calculator. Okay, so the square root of 64, well, that's a perfect square because 8 times 8 is 64. So I know that this one is going to be 8. But the cubed root of 64 is 3 digits, or a digit to the third power. So the cubed root of 64 is 4. Okay, so that's kind of interesting because 8 times 8 is 64, so the square root of 64 is 8. And then 4 times 4 times 4 is 64, so the cubed root of 64 is 4. Next, we have to round to the nearest hundredth place. So the square root of 75 is not going to be a perfect square, and it says round to the hundredths place. So for the square root of 65, I get approximately, so I do the squiggly equal sign, I get 8.66025, and so on. To round to the hundredths place, that's 2 digits past the decimal. I look behind there, and if that number is less than 5, it just stays the same. So rounding this, it becomes 8.66. Next, we're asking the subset of real numbers for 2/5. Well, 2/5 is a fraction or a ratio. So anything that is written as a ratio is considered rational. It's also a real number, but it told us that in the problem. Okay, next it says order the following numbers on the number line, and we're going to plot the given numbers on the number line and label them. Okay, so I'm still going to use my calculator to kind of help me out. 9 over 4, 9 divided by 4 is 2.25. So that makes it easier to see where that goes on the number line. So 2.25 would be before the halfway point. That's like 1/4 of the way through. So 9/4 just goes past the 2 right there. A negative square root of 10, so I'm going to use my calculator for that, and that gives me approximately negative 3.162. So negative, just past the negative 3 mark. So right here is the negative square root of 10. And then the last one, let's see, a negative exponent makes a smaller number. So this decimal is going to go 2 positions to the left. So that's going to give me negative 0.0862. So that is a very small number. That is going to drop right here. And then I write the original value. Okay, so then you can see now they're ordered and on the number line, and I put the given numbers on the number line. Okay, for the last set, this set, we're going to classify if it's rational or irrational. Go ahead and use your calculator. The square root of 55 gives us a very long number, 7.416 and so on. That's it doesn't terminate, it doesn't repeat, so that's irrational. And then we can explain it. So we could say something like it's approximately 7.416 ... which is a decimal that doesn't terminate. It's not a perfect square. It doesn't terminate or repeat. Okay, so I think if you say it's not a perfect square, that should be sufficient. Okay, the square root of 77. Okay, so when I put that in, the square root of 77 is approximately 8.7749 ... So you could see again, this one is going to be kind of crazy. We call it irrational. So it's not a perfect square. Okay, so the same reason there, it's not a perfect square. And the square root of 4, well, I know 2 times 2 is 4, so the square root of 4, this one is going to be rational because the square root of 4 is 2. So this is a perfect square. Okay, so that's that. Make sure you have your explanations. All right, so negative 8 is a rational number. We could write it as a ratio, negative 8 over 1, and it's still negative 8. So it is rational. What other subset is it? It's going to be considered an integer because integers are positive and negative whole numbers. Remember, natural numbers are our counting numbers beginning at 1 and up. Whole numbers begin at 0 and go up. And then integers go both positive and negative. Okay, number 11, negative 1.3, it's repeating. So if it repeats, it's rational, and then that would be our reason. It's rational because it's a decimal that repeats. Okay, so that explanation would suffice there. And again, we're going to put these numbers on the number line and put the given number back on the number line. So go ahead and use your calculator to do the square root of a negative square root of 8. So that's going to be approximately negative 2.828 and so on. So the negative square root of 8 would fall just past the negative 2, but almost at 3. So it'd be about right here. So negative square root of 8. And with scientific notation, negative exponents mean we move the decimal back 1 position. So it's 0.05625. So that'd be about right here. Again, put the given value back on here. And then 9 divided by 4, that's the same one we had before, is 2.25. It's the same thing as 2.25, so that would go right here. 9 over 4. Okay, again, make sure you put the given values on place those on your number line.